This is the Grout CG600 high-speed, high-shear colloidal mixer. This particular unit has an electric over hydraulic power supply. The electric motor powers the hydraulic pump right next to it. This video will explain the parts and functions of this mixer, as well as explain how it differs from an air-powered grout plant. On the electric over hydraulic grout plant, the panels of controls operate the pump. It's equipped with an emergency stop and a start and stop button. The emergency stop needs to be pulled out to run the machine. Pushing it in brings all the operations to a halt. All these controls can control the speed by how far you push the lever in the on direction. The bridge breaker lever controls the bridge breaker mixing paddle as grout is being mixed inside the mixing tank. The grout will recirculate through the mix tank down through the inlet to the colloidal mixer at the bottom. One hole is the drain, the other is the inlet for the colloidal mixer. The colloidal mixer is used for high shear mixing of the grout. The speed of the colloidal mixer can be adjusted by rotating the lever. The suction inlet to the colloidal mixer comes back from the mixing tank. The grout is mixed through the colloidal mixer and then runs back through the hose that is directed by the pinch valve. The pinch valve can operate in either direction to run back into the colloidal mix tank or transfer grout into the agitator tank. Please note, there is a drain cap at the bottom of the colloidal mixer. Before the first batch is mixed, the cap needs to be taken off to drain any residual water that could be in the tank. Once the grout is fully mixed, the lever for the pinch valve is flipped. This redirects the fully mixed grout that's coming back through the colloidal mixer up through the hose and into the transfer pipe that runs into the agitating tank. The full batch of grout will stay inside the agitating tank until it's ready to pump. As the grout is transferred from the colloidal mixer into the agitating tank, it runs through a screen. The screen catches debris to make sure it doesn't get into the pump. Inside the agitating tank is a paddle that spins to keep the grout fluid. You can hold several batches in the tank. The mixer agitator lever is used to control the mixing panel in the agitator tank. The grout pump lever controls the pump that injects grout into the tendon. Here is the progressive cavity pump. The hydraulic motor spins the shaft on the rotor, and that will push the grout through the pump into the hose. The grout will come through the agitating tank through this connection, pump into the inlet, and then will be pushed through the rotor and progressive cavity pump through the piping to the tendon. The piping here is one feature that you will see on different plant types. This lever can be used to throttle the flow of grout to either recirculate the grout back to the agitating tank or send grout to the tendon. A similar recirculation system, also known as a grout header or recirculation tee, is shown on this air-powered grout plant. The previous grout header was attached directly to the plant. This header is attached to the plant with a hose so that it can be placed near the tendon inlet. In some cases, you may want to be able to limit pressure into the tendon. If working with tendons that require a small volume of grout, it may be difficult to keep pressure low with larger grout plants. The grout comes from the plant through this hose and into the assembly, where it splits and either flows into the tendon or recirculates back through this hose into the agitating tank. The valve under the gauge is throttled to increase or decrease the grout flow to the tendon. You want to start with the valve open for the grout flow that goes back into the agitating tank. If you need to send more grout flow into the tendon, you can always close it further, directing more grout into the tendon. Another valuable feature that you will see mounted on different types of grout plants is the water tank. This simplifies the water measurement when several batches need to be mixed. For the first batch, once the grout plant is set, the tank needs to be calibrated. To do that, pre-measure the water for the correct amount per batch using a scale or trusted volume measurement. After the water is poured into the tank, you can use the overflow pipe as seen here to set it at the correct level. There is an inlet line where you can attach a hose. There is also a lever to switch it on and off. A sight glass is there for a visual to see the height of the water. Once you have the correct amount of water, you can use the valve to introduce the water into the colloidal mixing tank. Once all the water is in, close the valve and measure the next batch of water. Some of the main differences between the plants are: the electric power grout plant has a central control panel. The air-operated unit has valves on various air motors that are in line with the air lines. The air mixer utilizes an air motor. Above the motor is an inlet hose. The air motor beside it drives a belt that drives a colloidal mixer. The bridge breaker paddle is powered by an air motor instead of using a hydraulic motor. And there is also a similar motor for the agitating tank where the air motor powers the mixing paddle inside of it. An air motor also drives a belt which powers the progressive cavity pump. It is guarded to protect hands and feet from the belt. There is an automatic air oiler. It's used to supply oil to the air brought into the grout plant to help lubricate motors and keep them functioning properly. You do need to occasionally make sure it's still full, although this type has a relatively large capacity and should maintain for several grouting operations. If it ever has to be taken apart, make sure the pressure is relieved first. Attached is a cable that serves as the inlet for air brought in from the compressor into the grout plant. There is a whip check on the hose. This ensures that if there is a failure, the hose will still be held together. Make sure the hose is sized properly and has the correct pressure rating. Refer to an instruction manual for those specifications.